Hello everyone, I am Shuputra Pancha, Assistant Professor, Department of Computer Science and Engineering, PhD is VP Dr. PG Halkatti College of Engineering and Technology, Jaipur. So in the last class, we have discussed something about basics of hash functions, then non-crypto hashes. So a few examples about that non-crypto hashes. Now in today's class, we will discuss crypto hashes. There are different algorithms that are already there hashes. So already in the previous semester, I think in the cryptography network security subject, I already have studied in that. Some of the hash algorithms we have studied. Those are MD5 algorithm, that is message digest file, message digest algorithm. That is also one of the hash. And along with that, one more is SHA, secure hash algorithm. So these two algorithms are there to calculate the hash value of a particular input data. Now, with reference to these two hashes, we will be studying one more hash algorithm in this, that is TigHash. So, already the popular process that what I told just now, MD5, that is invented by Rivest, of course, 128-bit output. So it takes 64-bit input, each will be of multiple of 64-bit, then always it produces the output as 128-bit. So MD5 collisions easy to find, so it's broken. One more is SHA1. So briefly we'll discuss about this. Actually these are not concerned in this particular syllabus. Then SHA1, that is secure hash algorithm, the US government standard, similar working to MD5, but it produces 160-bit output. Many other hashes, but MD5 and SHA1 are the most widely used. Hashes work by hashing message in blocks. So what we have to consider is we have to consider input in terms of blocks, and will produce these algorithms will produce the output in terms of blocks, that is in terms of bit output. So how actually the crypto hash design is? So it's a desired property avalanche effect. So that is change to one bit of input should affect about half of output bit. So anywhere in the input, if you change one bit in the input, it should affect at least half of the output bits. That is what avalanche effect. That's nothing but crypto hash design. Crypto hash functions consist of some number of rounds. So what actually this hashing is? So initially we'll be considering some data in the form of bits, maybe 64 bits, right? So a multiple of 64 bits, it may be up to 512 bits. One exact round will take 512 bits, like that. So that will be divided into 64 bit each. That is nothing but input here. So here in this, once we provide the input to the particular hash algorithm, it will be uh, it will be passing through many rounds in between, so that those 64 bits of data will be gets confused and diffused in the particular round of hash, that is particular round of hashing algorithm. Then after that, after some rounds of hashing, it produces the output, so that there is a confusion in the data, so that it takes the 64 bits as the input, and it produces some bits, some number of bits as the output by passing such input to many rounds of hashes. That is what we can call it as a hash design. So in this way, we'll go for the hash design. That is what crypto hash functions consist of some number of rounds for security and speed. So avalanche effect for few rounds, avalanche effect is nothing but what uh, change to one bit of input should affect about about half of output bits, but simple rounds. So it goes with the simple rounds. It produces almost confusion, that is avalanche effect after few rounds. So whatever the rounds if you go through, those are very simple rounds, analogous to design of block ciphers. So here we are giving the input in terms of block, not stream ciphers. So block in the sense block by block. So assume that our data is of 1024 or 1025 bits, and that will be divided into 512 bits each. Say for example, and again it is in turn divided into 64 bits each. That is nothing but a block. So that are going to give input as a block by block. So as I said, so in this particular hash functions, we'll be studying in detail about TigHash. So what is actually TigHash? Very simple term. It is fast and strong compared to now. Already you have gone through MD5 and SHA. So those are very those are widely used actually. But apart from that, there is one more hash called as TigHash. It is fast and strong, designed by Ross Anderson and Ellie Beham, leading cryptographers. So design criteria. What is actually the design criteria? Very first point we need to go for TigHash is it provides secure because it goes through many rounds of hashes in between input and output. Second point is optimized for 64-bit processor. Then third point is easy replacement for MD5 or SHA1. This is what TigHash. So let us study a little bit about this TigHash. So like MD5 or SHA1, similar to MD5 or SHA1, here input, that whatever input we will consider, that input is divided into 512-bit blocks, padded. Something is written there padded. Why it is written there padded? Your input data may consist of 560 bits or 570, 600 bits, whatever. So to the next 64-bit level, we need to pad such bits. If it is 500 bits, assume it, then what we have to do is we have to add extra 12 bits to that. We have to add extra 12 bits to that existing 500 bits to make it 512-bit blocks. So that is what input is divided into 512-bit block padded. Unlike MD5 or SHA1, output is 192 bits, 364-bit words. The input for the output for this particular TigHash, what we are going to get is 192 bit. So truncate output if replacing MD5 or SHA1. Intermediate rounds are all 192 bits. So whatever the rounds it goes through, all are 192 bits. Then in this, I think you might have studied something about yes boxes, substitution, some substitution boxes. It will substitute one bit with the sum of the bits. So that is what to create a confusion. So here it uses 4 yes boxes, each map 8 bits to 64 bits. So assume that in particular round we have 8 bits. Each 8 bits are mapped to 64 bits. I mean 8 bits are converted into 64 bits. 8 into 8. So each 8 bits will be mapped to 64 bits. That's what yes boxes. Yes boxes is always termed as substitution boxes. It substitutes one bit with the another bit. So like that, in generally what I can say, 8 bits to 64 bits. And along with that, very important one, key schedule is used. So I mean, key will be used in almost each round. So that detailed block diagram, it will be there. So I'll discuss it in the next slide, upcoming slide. So this is what the TigHash is. So just intermediate rounds are all 192 bits, 4 S boxes, each mapped 8 bits to 64 bits. A key schedule is used for each round. So now you can see here, this is a generalized uh, block diagram for how you are going to create a hash with the different steps in between. So here in this, now you might have seen here, there is something else. Input is A, B, C. Those are in terms of blocks, I'll tell you. Then in between that, there are different functions available here. For each function, it takes some input. There is a W. So I'll tell you what is that XI, W, and key schedule. So that what I said about that. Then each FI will produces 3 outputs, and in each round, 3 input will be given for each round, and it produces 3 outputs. But actually, I'll tell you what is exactly this A, B, and C, and details about uh, each inner round, what actually it does, and something about what is actually this XI, W, and all. Right? So now you can see this. So input is x. Assume that input is x. So x equal to x naught, x1 up to xn minus 1. X is padded. Each xi is 512 bits. So now what x it is showing here, this is nothing but how we are making use of key schedule. So it is what each xi is 512 bits. Is actually padded. So you can see that that is what we can call it as a input here. So each xi is 512 bits. There are n iterations of a diagram at left. So one for each input block. So here xi is converted into w, and that w will be given as input to the first intermediate function, and again key is scheduled, and again the next w is given input to the f7 function. Like they have named these functions as f5, f7 and f9. Now along with that, along with this data, that is actually xi, will be considering some inputs. Sorry, will be considering some constant. So, for each hash, we will be considering some of the constants as a comma b comma c. Those are again in the form of what 64 bits. I'll tell you that. Final ABC is your hash. So whatever the output in terms of ABC you are going to get, that is nothing but your hash. Looks like block cipher. Blocks are replaced here. So very simple. Xi is your data, and it is padded up to 512 bits. And in the first round of that function, W is given input to Fi, as well as ABC is given to input to the Fi, and produces again three components ABC as output. And for the next round F7, W is given input. So before producing the next W, that particular W is scheduled in terms of key. That key is going to be changed. That is what key schedule. Anyhow, very simple. W here is 512 bit data as input, and ABC as in terms of 64 bits. A is 64 bit, B is 64 bit, and C is 64 bit. So totally what output we are going to get is 64 into 3, which is 192 bit output. And how we are going to get? You can see this ABC is given input, and it goes through F5, it goes through F7, it goes through F7, F9, and finally that output from F9 will be XORed with the original A. Output from F9 is substituted with the original B. Output from F9 is added with original C. That is the binary addition, binary substitution. This is normal XOR. And out, after that, what we are going to get, that is nothing but A, B, and terms of 64 bit, 64 bit, and 64 bit, totally 192 bit. This is what general round of Tiger. This is Tiger outer round. So now in the next class we will be discussing. In the next class we will be discussing about Tiger inner round. That is what F5. Thank you.